Welcome to This Explainer. Today, we are jumping right into the fascinating intersection of humanity's absolute oldest physical records and today's most advanced artificial intelligence. We're looking at a profound transformation in how we interact with our own history. You see, through ambitious initiatives like the CD-Vacay project, modern technology is stepping in to help us digest ancient data at a scale that we previously thought was just impossible. We're bridging a massive gap today, mapping out exactly how researchers are using cutting-edge tools to unlock the secrets of the ancient world.
To really wrap your head around the leap we're taking here, imagine this stark contrast. On one hand, you have 4,000-year-old culinary recipes, meticulously etched into these fragile clay tablets by ancient scribes. And then, in a completely opposite realm, you've got modern Python CLI scripts, those text-based command tools developers use to orchestrate complex AI automation. We are taking the incredibly archaic and bringing it directly into the cutting edge. By using modern generative AI platforms like Google's NotebookLM, historians and data scientists are building entirely new workflows to manage, organize, and synthesize our ancient past. This isn't just a minor upgrade to a filing system, it's a monumental technological leap in how human history is actually processed.
And this matters so much because of the sheer scale of the problem we're facing. Just think about this number, 500,000. The Cuneiform Digital Library Initiative, operating under the broader goals of the CD-Vacay project, has recovered and cataloged an astonishing 500,000 ancient tablets dating from 3350 BC all the way up to the pre-Christian era. That is 500,000 distinct instances of human thought, commerce, poetry, and culture. To put that into perspective, if a scholar read just one tablet a day, it would take them over 1,300 years just to read the collection once. It is a literal mountain of data.
Now add to that the massive archives of the Yale Babylonian Collection, which holds about 40,000 digitized items. And we aren't just talking about dry, ancient tax receipts here. These are the vivid highlights of early human civilization. We have the world's oldest known culinary recipes, which honestly would probably make for a very earthy stew today. There's a mathematical school tablet where an ancient student actually approximated the square root of 2. We've got a manuscript of the legendary Epic of Gilgamesh and poems by Enheduanna, who literally holds the title of the very first named author in all of world literature. When you look at the breadth of all this, it becomes glaringly obvious that this explosion of digitized historical data is physically impossible for one human or even an entire university department to manually cross-reference.
So, to handle this massive, invaluable archive, AI tools are stepping in as the ultimate sidekick. Historians are finding that AI platforms, specifically those using Retrieval-Augmented Generation, or RAG, operate as an extremely smart polyglot research assistant. And just to break that down real quick, RAG basically means the AI actively fetches relevant, sourced facts from a massive database before it even attempts to answer your question. This gives us a tool capable of semantic search across absolute oceans of print. It can read Sumerian, Akkadian, and English simultaneously. It pulls up leads, tracks trade routes, and identifies themes that a human researcher would quite literally spend a lifetime trying to locate in a physical archive.
Section 2. The Context Collapse Trap, when AI reads too much, too fast.
Because, as amazing as our brilliant AI sidekick is, when it faces dense, complex historical layouts, we run into some pretty severe complications. The crucial point here is that AI completely lacks visual common sense. It falls into what researchers call the trap of context collapse. You see, a historical newspaper or a densely packed ledger is a carefully constructed visual object to a human eye. But to an AI, it's just a flat wall of text. The AI's internal process for breaking text into manageable chunks really struggles to separate one story from another. This means it might incorrectly merge completely unrelated text on a single page, like stitching together a highly serious political editorial with a nearby advertisement. You can imagine the headache if a historian accidentally published a paper claiming some legendary leader heartily endorsed a local brand of bath soap. It completely destroys the contextual integrity of the source material.
Alongside this context collapse is a related, deeply frustrating issue called temporal flattening. AI doesn't inherently understand the linear progression of time, unless we specifically structure it to do so. So, temporal flattening happens when the AI essentially hallucinates new historical narratives by blindly blending quotes and events from entirely different days, weeks, or even years. It just erases the historical specificity of the events it reads. It might conflate a passionate speech by a reformist leader with the angry reply of a conservative senator, treating them as a single continuous thought just because they happen to be digitized in the same batch of documents.
The difference in how AI processes layout formats brilliantly illustrates this technical glitch. Let's take two historical German sources for comparison. First, consider Die Neue Zeit. It has a linear, book-like, single-column format. The AI easily understands it because human reading and AI reading actually align here. Each chunk of text corresponds to a coherent, top-to-bottom argument. But then, look at Vorwärts, which is a late 19th century daily newspaper. It has a really dense multi-column layout. Human eyes naturally see a vertical column break and know to stop and read downward, right? AI, however, simply reads left to right. It blindly crosses those column boundaries, mashing two completely different articles into utter gibberish. This total lack of visual common sense leads directly to that context collapse we just explored.
Section 3. The PPAE Prompting Loop. Taming the Polyglot Assistant.
So how do we actually solve these layout and timeline hallucinations? Well, the human researcher has to step up and be the hero, taming the AI sidekick using highly structured prompt engineering. This all builds into what's called the PPAA loop: perceive, plan, act, and evaluate. It's a really actionable, repeatable mantra for guiding the AI's retrieval processes. Step 1 is perceive. Upload your sources and identify the knowledge gaps. Step 2 is plan. Carefully choose your desired format, the specific scope of your search, and the depth of reasoning required. Step 3 is act. Actually write out the structured prompt based on that precise plan. And finally, step 4 is evaluate. Rigorously check the AI citations and accuracy. And for ambitious undertakings, like the CDVK project, this evaluation phase is tracked using what are known as tetrahedral locks. It's basically this highly robust, multi-sided validation system designed to ensure absolute historical integrity and track progress across these massive datasets.
Now, the difference between just guessing and utilizing structural precision is practically night and day. Consider a simple comparison between a bad prompt and a good one. A bad, vague prompt is just typing, "Summarize this article." It leaves way too much open to the AI's interpretation, which practically invites context collapse. A good, structured prompt is highly intentional. It defines the role as an editor, demands the format be a bullet list, strictly limits the scope to the provided text only, and caps the output at exactly 5 items. By explicitly restricting the AI's boundaries, you eliminate its tendency to hallucinate. In fact, research shows that specifying the format produces usable, accurate outputs 87% of the time. Compare that to a dismal 34% for unstructured conversational prompts.
Section 4. Scaling AI Automation, Reaching Research Mastery. All right, once you conquer the basics of the PPAE loop and those tetrahedral locks, you can move to true mastery by scaling your entire research workflow. Researchers and developers are pushing the boundaries way beyond basic prompts now. They're utilizing axiomatic prompt engineering, which essentially means embedding unshakable foundational logic rules directly into the AI's core instructions before it even begins a task. Inside platforms like NotebookLM, users are leveraging advanced auto-labeling features to instantly categorize and organize hundreds of dense historical sources. And over in the developer space, people are deploying custom automation toolkits to achieve parallel generation of study artifacts. This means automatically extracting synthesized, historically accurate knowledge and instantly formatting it into tools like Obsidian, Notion, or Anki flashcards, which, by the way, use spaced repetition to help humans memorize the data the AI just processed. It's a fully modular, automated research engine.
Which brings us to the end of this explainer, leaving us with a truly profound concept to ponder. As we successfully bridge this massive gap between 4,000-year-old clay tablets holding ancient recipes and modern AI automation script generating flashcards, how will having a machine that can read our entire recorded history simultaneously reshape our understanding of human memory? When AI can synthesize 500,000 ancient thoughts in literally seconds, what does it actually mean to remember our past? It's a thrilling and, yeah, perhaps slightly intimidating frontier. Thanks so much for learning with us today. Keep exploring, and I'll catch you next time.